Okay, YouTube community, delighted to have you guys on. If somebody can just post a comment that you can hear the audio, then we'll have end-to-end confirmation that the stream is working. For everybody else, we're about to start the meetup. People are starting to trickle in. Great seeing people flowing in. We have a couple of great talks plus some community news, and we'll get started in just a minute. What I'm going to do in the meantime is, well, first of all, I'm going to show who I am. I'm Robert Hodges. I run this meetup and have for a number of years. I live in the Bay Area, so it's pretty easy to get here. So let me go ahead and for people joining, I'm going to go ahead and just allow people to talk. We've found that it's just more fun if people can open up and say hi. By the way, Tatiana and Christina, welcome. I can see you both. So if anybody wants to say hello, introduce where they're from, you're welcome to do it. And this, I'm going to give people just a few more minutes to come in, so we're because people are trickling in. Starting to build up an audience. So while we're waiting, I'm just going to babble about a little bit of news in the community. I don't know if anybody has looked at it, but is running Java apps. If you do, you probably know about this CVE related to Log4j 2 version 2. We actually published a blog. I work for Altinity. We published a blog article on Monday night, actually Tuesday morning, and just sort of with the latest on that. In general, ClickHouse is not vulnerable to this. ClickHouse itself is not vulnerable because it's written in C++. So, hey, no danger there if for Java vulnerabilities. But we did look at Zookeeper and other, as well as the ClickHouse JDBC driver, and posted that. I will post the link to that in case anybody's interested. If you are running Java apps, it's definitely something you want to check out. It's probably one of the worst exploits in years that's come up. It basically leaves you wide open to have people inject code into your onto your host. So definitely something to look at. With this, I'm going to get going, and I'm delighted to have a couple of great speakers here with me today. I've got Rocco Cruz from RedPanda. I've also got Graham Mannering, who's on our team, who'll be doing a talk with me. We're second up in the batting order, and we'll be talking about Kubernetes. And before we do that, though, I'd like to just go over a few community events, deliver some news that you may be interested in. And so first off is just sort of some near-term things. On December 16th, that's tomorrow, there is the monthly ClickHouse release webinar from our friends at ClickHouse Incorporated. You can, if you can hold your phone up to the screen, you should be able to see this QR code, which you can use to go and sign yourself up. It pops up a calendar entry, I believe. There's also a bit.ly link here that you can use to sign up. These are really worthwhile. So, and I believe Alexei Milovidov and friends will be presenting on this. Second, on February 16th, we're planning to have the next SF Bay Area ClickHouse meetup. So if you don't go to Alexei's webinar, or can't be troubled to go somewhere else, you can just come here and hear about the whole 2022 roadmap. I don't think Alexei will be doing it because I think he has a conflict, but we'll have somebody off the team that will do it. Another one that we're trying to line up, we have a tentative acceptance, is from the folks at Materialized. Nothing to do with ClickHouse, but they do materialized views in a really interesting way. That's such a big feature on ClickHouse. It seems like it'd be interesting to hear from them and what they're up to. And then we have a slot for another talk. So anybody else, if you want to do a talk, if you have something cool to share on ClickHouse, we'd love to have you present. We're always looking for people who are doing new apps, doing new projects related to ClickHouse and analytics. The closer it is to open source, the more we like it. We try to focus on open source stuff that you can use. So once again, I'm Robert Hodges, CEO of Altinity, Database Geek. I've been running this. What I'd like to do is, before we start Roko's talk, let's go ahead and anybody who would like to speak up, I've tried to unmute as many people as I can. If you'd like to speak up, say hi, where you're from, that'd be really great so we can hear who's joining us today. So I see Alexandra Faria. We can just do it in alphabetical order if you'd like to, for the Zoom attendees. So feel free to sing out and say hi. Don't be shy.
Hello.
Hi. Who was that?
It's me, Alexander. I'm just a bit curious about ClickHouse, so I'm not sure if I have anything useful to say, actually. So.
Okay. Are you using ClickHouse now?
No, not really. I was curious about it, so I ended up here basically to know a little bit more about it.
Welcome. We're delighted to have you attending, and I'll help you learn some useful information from it. Let's see, next in the list, Alon.
Hey everyone, Alon. I work for Tesla, the car company, and we are ClickHouse users.
Awesome.
Yeah, we've spoken before, Robert. So
we have. That's right.
Yeah. So good to be here. Thanks for hosting this.
You guys should do a talk sometime if you can. Unless ClickHouse is a secret weapon, then you can't tell us what you're doing. But that'd be pretty cool.
Yeah, I'll talk to my manager and see whether it's okay.
Awesome. Andre, you want to say hi? We've got a couple Andres. Just feel free to sing out.
Hello, it's Andrei Mishinkin from Unity. Actually, we now evaluating the ClickHouse as a tool that we can use for our some projects. So interesting to join this event.
Wonderful.
Mm-hmm.
Andrei Monakhov.
Yeah, hey Robert. And everyone. I'm Andrei Monakhov, and I work for Altinity a couple of years. So I'm just attending here to know more than I already do in ClickHouse.
Welcome again. And Andre does the UI on Altinity.cloud. So you've seen it. If you use Altinity Cloud or have trialed it, you've seen his work. Let's see, Boris.
Yeah, my name is Boris Kushel, and yeah, so I'm just I work for IBM, and yeah, we are interested in ClickHouse as well, and we're looking to kind of work with ClickHouse and also do some like development on it as well. So we're really interested in participating in the open source community in the near future. So yeah, I guess that's me.
Welcome.
Thank you.
Great, Brian.
Yeah, hi, this is Brian Hunter. I'm with ClickHouse. I'm actually driving right now, so I can't really talk, but thanks for putting this together.
Oh, you're most welcome. We're delighted to have you. Let's see, Andrew Chan, I just allowed you to talk if you want to speak up.
Hello, my name is Andrew. I currently work for Lyft, the car company, rideshare company, and we're starting to use ClickHouse, so very excited about all the new features and usages of it.
Cool. Let's see, Gilad, if you have audio.
Hey.
Welcome.
Hey, I just joined.
Great.
So,
welcome, Gilad. If you want to just say hi and where you're from.
Hey, I'm from Israel, and I work in a startup that uses ClickHouse.
Great. Thanks for joining us so late. Let's see. I think Greg Jacobs is next. Oh, wait a second, Greg. I think we already got you. Sorry. Jay.
Hey, this is Jay, working for Palo Alto Networks. And yeah, I'm evaluating in ClickHouse, right? And then I wanted to learn ClickHouse in many perspectives, the technology, a plan, and so I want to join as many as possible. And thanks for Altinity for hosting this.
You're welcome. Yeah, and welcome again. I think you've been on previous meetups. So that's great to see you again. And let's see, we have Christina. If you have audio, all right, we'll keep moving. Kyle.
Yeah, I'm an Arctic Wolf with Greg.
Oh, hey, Kyle. I think we've talked before.
Yeah, I've been to a few of these now.
Okay, great. Yeah, welcome. Wonderful to have you. Great. How about Liam? If you have audio, I'll keep going. If you don't, Nico.
Hi everyone, Nico Acosta here. I'm with Propel Data Cloud. We're an analytics API platform for developers to easily build customer-facing analytics.
Cool. Have you guys ever considered doing a talk? That sounds like exactly the right stuff. That looks really great. That's really great.
Not yet, but would love to explore that in the future.
Okay. Ramazan Palat, welcome.
Hello, can you hear me?
Perfectly.
Hello, good night. I'm just here to learn something more. I'm a ClickHouse fan. I work for SEO.do, and we also use ClickHouse there.
Wonderful. It's great to talk to you again. So welcome to the meetup. And then finally, we have Yuri Shachov, I think. If you want to just say hi.
Hi there. My name is Yuri. I'm working at farm company in Moscow. And I just asked some question in Slack. And one of my colleagues sent me a link to this meetup. And no, I don't know why I'm doing it, but I'm really interested in ClickHouse and I'm working with it. And maybe I will ask my question just later. So have a great time.
Perfect. Thank you so much. So we do have, I want to introduce one more person who's on the call today, Tatiana Saltykova, my colleague, and the total expert on ClickHouse. Tatiana, I hope you'll be able to stay on to the Q&A, but
Yep.
So
hi everyone. My name is Tatiana. I'm a support specialist at Altinity. And yeah, if you have questions, you can post them in the Q&A sections probably. And yeah, I'll try my best.
Tatiana has forgotten more about ClickHouse than certainly I've ever known, and most of us for that matter. So thanks, Tatiana. It's great to have you on. Okay, that's it. Welcome, everybody. And for those of you on YouTube, great to have you on. I can see about 16 or 17 of you. I'm going to go ahead and turn this over to Rocco Cruz. Rocco works for on RedPanda. He's a dev advocate, and he's going to be talking about introducing RedPanda and talking about integration with ClickHouse. So I'm going to stop my share. Go ahead and take it away, Rocco.
Perfect. Thanks so much, Robert, for the introduction. I really appreciate it. I'm Rocco Cruz. I work at Vectorize, and I'm going to be taking you through a bit of RedPanda and also a quick little demo too as well. So let me just share this, put that in presentation mode. Okay, perfect. So we'll talk about the integration with ClickHouse, but first to give you kind of a quick introduction to RedPanda itself. RedPanda and ClickHouse actually do share a lot of similarities in many ways. But what is RedPanda? Well, so RedPanda is a streaming platform that is fully Kafka API compatible. So, I imagine a lot of people out there today are using, using Kafka with ClickHouse, and RedPanda is a fully compatible replacement for that. So anything that works with the Kafka API works with RedPanda right out of the box. We have really focused, though, on a more high throughput, low latency, and also doing durability right out of the box. The project itself started back in 2017 by a number of core developers that have really focused on overall low latency. So a lot of people that have come from building Ceph. Actually, we have a few core engineers from Yandex that actually worked on ClickHouse at one point as well. And a number of people from the big data space from the likes of like Cloudera and such. The source code is available. It's out on GitHub in the Vectorized IO organization. It's underneath a BSL license that pretty much allows you to do anything with the software as long as you don't create a public service that you sell to everybody else. So pretty much the Amazon clause that exists today, but that's about it. And we'll talk a bit about the performance and the operational simplicity of it too, as well as we get into the presentation. So how is this similar, or how is RedPanda similar to Kafka? And I'm kind of making the assumption that people are familiar with Kafka today, and that might not be a fair assumption, but what Kafka really provides is a publish subscribe model. So you can publish messages to it and subscribe to it. And you have what's really called producers and consumers. Those producers can produce to a topic, and a topic is made up of a set of partitions. Those partitions are like shards in the database or anything else from that standpoint. And within a partition, everything is, for all the keys within that partition, you have guaranteed ordering. And then consumers consume typically on a per partition basis. And then that way that you can have, you don't have global guaranteed ordering, but you do have ordering within a given partition within the system. And so you have, namespaces, topics, and partitions. There is the idea of brokers. So you can have, you have leaders and followers, and there's replication that's occurring within the system as well. There are transactions. There's this idea of doing idempotent producer. So that way you can make sure that you're not creating duplicate messages. And then also the ability to do transactions or a transaction across multiple topics and partitions too, as well, from both a read and write perspective. There's also a schema registry that can define the schema that is used for messages that are sent to Kafka, because really by default, you just have a byte array that you send data to via the Kafka API. The schema registry allows you to specify what schema is going to be used for that data that's sent across. And there's also an HTTP proxy. These are all things that RedPanda has as well. So, very similar to the Kafka ecosystem. These are all the sort of same similarities that we have out of the box. Where is it different from Kafka? So first and foremost, it's around the operational simplicity. RedPanda is a single binary. We compile everything into a single sort of or statically link everything together into a single binary that we provide. We are using Raft within the system itself for all cluster state information, and also for all the replication that's happening within the system. We are using direct IO, so there's no page cache. So if you're familiar with Kafka, Kafka by default uses the page cache. Kafka is written all in Java, using the page cache was definitely the right choice for Kafka 10 years ago when it was first developed, because you didn't want to really give Java anything more than 16 gigabytes of heap space. Otherwise, you're going to have some large GC pauses. So they used the page cache within the OS to cache file system or the files that it was interacting with, which made a lot of sense because you were also probably running on top of spinning disks at that moment. So we don't use the page cache. We write to disk after every batch of messages for better data persistence and guarantees. We can do that today just because of a number of the optimizations that we've done within the system itself, and also using SSDs too as well. We are built entirely in C++. We also use a library behind the scenes called C*, which I'll talk about in a little bit. We do have transactions, And then we also have a few other things, which we actually just released a blog post on today around shadow indexing and WASM, which I'll talk about in a little bit more detail a bit later. So around operational simplicity, 100% CLI driven, very similar to ClickHouse in that regard. We have something called RPK, or RedPanda Keeper, which is actually a Go utility that interacts with the system and allows you to do things like topic creation and other things from that standpoint, very similar to the ClickHouse client in some ways. We have no reliance on external systems, so no Zookeeper. Kafka really heavily relies upon Zookeeper for consensus coordination and for cluster state, some cluster state information and membership management. We actually do that all within the system itself. So it's a single binary, as I was talking about. We also do a number of things around automatic leader and partitioning rebalancing in the system, which is quite nice. We really try to simplify the overall manageability of the system within RedPanda itself versus having to use external tooling to do that type of management. We auto-tune the kernel. So we set a number of things to use AIO and specific schedulers that are useful for us. We also are pretty opinionated on the file system. So we highly recommend XFS as we do things like adaptive F allocation and out of order direct memory access rights as well. We provide a Prometheus endpoint on every node within the cluster, so you don't have to use any type of exporter or anything from that standpoint. And there is also a Grafana dashboard that we build, and we'll actually see here in a second within the system. We provide the software as either a Docker image. We have a Kubernetes operator. There's Terraform and Ansible scripts that also exist out there today as well. So I'll just touch upon this really quickly. Raft is sort of the standard consensus protocol today. A few kind of sort of requirements that it has is that requires an odd number of replicas. For us, a partition within a topic, that partition is its own Raft group. So this allows us to do membership rebalancing and things like that pretty easily within the system. Single fault domain, since we aren't relying upon anything else externally, and also the leader only has to send out sends out updates to all of the replicas and only has to wait for a majority to come back before it makes response. So it can actually write out slowness in individual replicas within the system. So just a quick little note on some of the interesting components inside of RedPanda itself. So the C-star framework is a very interesting system. It's something that was first developed by the ScyllaDB company, and then they open sourced this core library component. It's been used by a few other projects too as well. It's a fully C++ framework, and what it really aims to do is to treat a system like a distributed system, or or treat a single instance or single machine like a distributed system in many ways. And what I mean by that is that it does a thread per core architecture. So when C-star first starts up within RedPanda, it looks to see how many cores it can have access to. It will spin up that many threads, and then we'll pin those threads to a specific core within the system. This allows us to have no locks. It minimizes IO blocking. And it also reduces overall context switching and allows us to preserve the cache lines within the system too as well. Because in these larger systems of what we're seeing today, you can have upwards of like 32 or 64 cores that you have access to. And then you have NUMA domains that go along with it. You might also have you have different like caches that go along with it too as well. So you might have like your different L1, L2 caches. And if you have to do context switching or move a thread from one core to another, you will most likely lose sort of the benefits of the cache, or the caches in those instances will have to be hydrated, or you're going to have to do a higher latency request to get to that cache or memory. So being able to be pinned to a given core allows us to reduce those, that overall latency, because the way that we really see it is that latency is the sum of all your bad decisions. And ideally, we want to make, as many good decisions as we possibly can, so that we're not adding to, the additional latency within the system. So what does this do for you at the end of the day? Or, what are the actual results? And this is actually from a blog post that we posted earlier in the year. We actually used the Open Messaging Benchmark, which is a Linux Foundation project, to do some testing against Kafka and RedPanda. And this was on a 500 megabyte per second workload on 3 brokers inside of AWS, and a message size about 1 kilobyte in size. And we had the more specifics and examples of how to actually run the benchmark within the blog post that you guys can take a look at afterwards. But you can see here, Kafka is about 15 milliseconds for your average end-to-end latency within the system. We were telling Kafka to persist after every batch of messages, just like RedPanda, so that it was a fair comparison in that regard. But we also do comparisons too, where we allow Kafka to actually do in-memory replication. The more interesting part is actually looking at the real tail latencies for the system. So, as you get these systems where you get out to the tail latencies, you can see that RedPanda, it gets out to about 150 milliseconds of latency for even the max latencies, and then for Kafka itself, you're typically seeing latencies of upwards of dramatically really increases at the tail up to about 3 seconds. And this is why we typically see people over provision their Kafka clusters, because they more often than not have to be able to or they want to avoid these like higher tail latencies within the system. So one of the things that's really interesting about what we're doing too as well, and what I'll kind of hopefully show a demo of here in a moment, is this ability to do shadow indexing within RedPanda. So a lot of the times, like as you have data come into a streaming platform like this, you typically age it out pretty quickly because it can be quite a bit of data. But if you're able to make use of a lower cost object store, you can store data for a much longer period of time. So what shadow indexing allows RedPanda to do, it's very similar to tiered storage in Kafka and other systems out there, is that as data comes into RedPanda, we save it locally to disk. And then once we hit a certain timer or file size limit, it also gets uploaded into an object store. This way that, even if you do have the data get deleted locally, the data is still available in the object store, and you can make a request or come in and make a request for data or historical data, and RedPanda will just automatically go and retrieve that data from the object store transparently to the client. So this actually is a very interesting use case where you could have ClickHouse rehydrate itself from RedPanda, and it can actually go all the way back from like 6 months ago or a year ago. And RedPanda would just automatically either pull the data locally if it's local on disk, or also pull it from the object store without ClickHouse or any downstream client knowing about that from that standpoint. We're taking this even further. So what I just announced, or what I just, the shadow indexing, this is a feature that just is being released this week. This other feature is something that we're doing early next year that we're under active development, which is this idea of having read replicas. So we could spin up separate clusters that are pointed to the object store that are just read only, that would allow me to run these heavier analytical workloads or do things like rehydrate downstream systems without having any impact on the operational cluster and the data coming into it. So we think that this will be a pretty interesting feature to enable a number of different type of more analytical focused workloads. The other thing that we're doing, I'll just talk about really quickly, we have a blog post that actually just got released today, I believe, around this, talking about the preview that we have, is the ability to do transforms within the system. So, this isn't a complex stream processing framework that we're building, but what this allows you to do is that we've embedded the V8 engine, or the WebAssembly engine, called V8, that allows you to do things like filtering, routing, and transformation of messages on the fly. So this can only work on a per batch basis of messages and doesn't go across batches, but allows you to do these simple transformations without having to send the data out to a separate system to actually just do the routing and filtering for you. So let's talk about ClickHouse and Kafka together. So, ClickHouse uses the libRD Kafka. It's the C, sort of like the standard C library for interacting with Kafka. Most of the configs that you that are there for libRD Kafka can be placed in the config.xml and the Kafka attribute. The other thing, or a few settings I had to make for the demo, is that I did have to set Kafka max wait MS. I think this is defaulted to about 5 seconds. I set it to 0 to wait always because I was doing some requests where I was actually going to the object store for historical data, and I was seeing some timeouts. The other setting is the auto offset reset set in the config.xml. So libRD Kafka by default, when you point it to a topic, doesn't actually want to go, it just only wants to read new data as it comes into that topic and not do historical requests. But with this allows me to create a table within ClickHouse where I can actually look at historical data on the system as well. So, it took me a little while to kind of understand this fully too, but any of these settings that you see in libRD Kafka that you would typically set, you would also want to set here too for ClickHouse and its way it's interacting with Kafka. I built just a quick little demo that I'll show you guys, and I have to thank Altinity for their work actually on the Kafka engine tutorial. I took a little bit of that and used sort of their example of creating temperature sensor data that actually is loaded inside of ClickHouse. I took that data from ClickHouse, loaded it back into RedPanda, and then I can read it back from RedPanda inside of ClickHouse itself. So without further ado, let's just go over and take a look at that. So this is my RedPanda instance. I can do an RPK topic list. I can see that I have 100. I have a topic called readings with 100 partitions. I can do something like an RPK topic describe readings-a. This is actually going to give me more information about the individual partitions, where the replicas are, where the leader is, and also tell me like what the offsets are, or the high watermarks are, where this is actually saying, this is how many messages or how many batches of messages are within every given partition. So now that I know that this exists over here and I actually have data inside of it, I can also do some just simple things like RPK topic consume. And you can see from here, oh, this might actually take a little bit because it's gonna try to go back in history. So I'll let that just run for a second here. But while that's running and coming back with some data, I can come over and take a look at my ClickHouse particular instance. So what I have here is I do have a ClickHouse instance. If I, first and foremost, I want to go ahead and create a Kafka table. So I'm going to paste this in. So what you can see here is that I've created a table readings queue ingest with some particular fields. I specify the engine as Kafka. This is my RedPanda instance with my topic. I specify the format because hopefully this is coming back now with data. You can see that this is the message that I'm getting back, which is here is the value that you can see as a comma separated list. And so when I look at this, I can specify that this is going to be a CSV format, and I've increased the number of consumers because by default that only does one consumer. And so I've at least set it to 4, but could probably be tuned a bit more to increase the number of consumers for that system. So one of the best ways to pull this data in and just kind of see this working is I'm going to go ahead and create another separate data using a merge tree behind the scenes, which just looks exactly like that initial one. And then I'm going to go ahead and create a materialized view on top of that that's going to start doing ingestion from the readings in queue ingest into the readings table that I just created. So now I can start doing a select. I'll do a select count star from readings. And you can see that this is going to be 0 initially because we're making that request and we're actually getting the data from the object store. And we're actually starting to populate this in. And the initial portion of the request can be a little slow because we are retrieving data down from S3. And just to kind of show you what that looks like, this is how we're storing the data inside of S3. We're using a lot of random prefixes because, at the end of the day, S3 itself is really just kind of a database object storage that is, if you don't do this, you're going to be kind of bottlenecked on a particular folder within S3. But in any one of these, you can see that if I dive into it a bit more, I have my particular partition ID, and then I can actually see the log files that are the segment log files that are being retrieved into the cluster itself. So, so you can kind of, you get a better view onto this where, now we can actually see data is coming in and it's coming in more regularly and more quickly and being updated into that table. So if I let this run, this would fully populate this with all the data from that topic and would do a full rehydration into the system as well. If I take a look at the dashboards inside of RedPanda, I can also see the information in this. I had to increase the font for this, so it's going to make it a little harder, but I can also see my latency and then the overall throughput that's happening within the system as well. The latency is a little high because I'm making requests to S3 and pulling that data back because I just really wanted to kind of show that, that ability to be able to do historical requests, but then you can also do the same exact thing for also real-time data into the system too as well. So, so there's you can kind of get a quick feel for how this all sort of works together. And gives you kind of an idea of like how you would use these two systems together in that regard. So if you found this interesting, you can definitely come and check out our source code or check out the project itself on GitHub. We have instructions for how to build it, how to contribute to it, and things from that perspective. We have a number of engineering blogs on our website that you can take a look at where we've done things like Jepsen testing on top of RedPanda for correctness and things from that perspective, and also the benchmarking blog that was also talked about as well. We have a community Slack channel that we'd love for you guys to join and come ask questions. And then if you want to reach out to have a further in-depth conversation, please come to our website and let us know. And with that, thank you so much, Robert, for the opportunity, and happy to answer any questions that might come up.
Sure. This is an absolutely awesome talk. And by the way, I hope I didn't strike panic into you when I turned the recording on. I didn't start the Zoom recording, but you're on the stream. We've got you for posterity, and we'll clip the talk, and you guys will have something that folks can link to. So yeah, I'd like to invite anybody who's has interest in this to queue up questions. You can put them in the Q&A box. If you're on if you're on the Zoom, you can actually talk. Feel free to put them in. Go ahead and put them on the stream. I have a couple. I used to work on this stuff full time. I did a lot of replication back in the day. So one of the things you said was you bumped up the number of consumers from 1 to 4, and I'm just curious. Can you talk a little bit about that? Sort of normally it is normal, pretty standard for us to only have one consumer in Kafka and then spread it across a bunch of Kafka table engines. How do you guys go about balancing that? What are the kind of things people need to look at?
Yeah, no, that's a good question. And, it's probably my lack of understanding of how the Kafka engine works specifically inside of ClickHouse. But, typically if you have only one consumer, and in this particular example, I have 100 partitions, that one consumer will have to be consuming data from all 100 partitions all at once. And each partition might come back a little more quickly or slowly or other things from that perspective. You can have upwards of the same number of consumers as you have partitions. So if I have 100 partitions, I could actually technically have 100 consumers, and each one of those could be getting a independent stream of data from a partition that can then be inserted or ingested into a downstream system. So, typically when we start sizing out like what a RedPanda cluster looks like, our typical limitation is about 900 megabytes to a gigabyte per second per partition that we can handle. And so, normally what we take into a factor is like, what's the data throughput look like? And also, what does your consumption look like? Will you be bottlenecked on having just 5 consumers with 100 partitions? or do you want to have 500 consumers on 500 partitions? Every use case is slightly different depending upon what you're trying to go for.
Great. Tatiana, I know you're listening to this. Do you have any pointers on, I know this is different from Kafka, but do you have any general guidance regarding this, and whether that's a sort of a reasonable approach to configuration?
Well, it depends on the system. I'd say it's like the amount of data and the number of partitions, and yeah, how the data is split inside Kafka or RedPanda. That's
Okay. We've got a couple questions coming off the stream. Okay, so one from Denis Zhiravlev. Some of you all probably know him as Denny Crane. Is it possible to have geo clusters? For example, consumers in the US, broker in EU, and producer in Asia?
Yeah, absolutely. You would have to just make sure that you have your timeout set accordingly for those types of setups. But yes, you could absolutely do that.
And I think another one is, do you, I think related, because that is, if it's a single cluster, can you also have a cluster that's split across multiple sites?
Not currently today. The way you would typically do that is you would use a tool like MirrorMaker to do replication from one location to the other. There's nothing stopping us from doing multi-region clusters. So we use a very similar type of wrap implementation that CockroachDB uses. And so this is definitely something that we have plans to support later next year. But just currently today, the highest amount of demand is for multi-AZ or single region clusters. I see there's another question in the that popped up in the chat around what was the purpose of the replicated merge tree table and materialized view in the demo? Is it possible to select directly from the engine equals Kafka table? And yes, you can absolutely select directly from that engine Kafka table. What ends up happening is that probably, I didn't highlight it when I showed it, but you specify a consumer group as part of that table. And what that consumer group specifies is to save the offsets that have currently been seen. So the purpose of creating that separate table that I did a materialized view into allowed me to take all of the data from that topic and materialize it or bring it into a table within the system. If I did a full select on top of that table, I could absolutely do that. But what would happen is that consumer group would update with the offset. So I could only do a select off of it once to get all of the data. And then if I went and did another select or another query on top of it, that would only bring me the data that was seen since the last query on top of that data set because of the consumer group that's actually being specified. So that's the reason why that you would want to actually pull the data and put it into a separate table if you wanted to store the full history of it and not just capture the changes that are coming into the system. How production ready is RedPanda? Is it still production ready feature? Is there still production ready features that are not yet implemented? Great question. Actually, just earlier today, I did a webinar with one of our customers, Alpaca Markets. They're actually using RedPanda for their order management system, where they're doing, I think they're doing a couple $100 million of trades per day, and they're using RedPanda as their write-ahead log as part of that order management system. So it is, absolutely production ready. We have another customer that is using it to handle with a 3-node cluster. They're able to handle all market data from the New York Stock Exchange, and then they're using that for trade execution and for pricing data and things like that within their organization. So yeah, it's definitely production ready, it's used in a number of places today.
Great. I have another one off the coming off the stream. Wondering if either of you, I think one of those might be me, have an opinion on using the internal ClickHouse Kafka table client or versus something like ClickHouse Syncer. I don't know enough about ClickHouse Syncer to comment on that. Tatiana, have you used ClickHouse Syncer before?
No, I don't know what it is.
Yeah. One thing I can say on that because Rocco, there's a question here, a related question, which maybe we'll take. Does RedPanda support exactly once producing and consuming?
Yes, it does. We support idempotent producers and also the ability to do transactions across topics.
Okay, great. Because that's pretty important for the answer I was going to give related to ClickHouse Syncer, and that is that we are working with some of our pals at eBay, and we have a potential solution that they may open source that does deal with idempotent apply to ClickHouse. So I'm hoping that we'll actually have them come talk about it at the next meetup. This is a topic that has been on a lot of people's minds, and we believe that it will work just fine with, with RedPanda. That's actually something we're going to be testing out pretty soon, as soon as the code's open. Hey, you guys have struck a nerve here, Rocco. Does RedPanda support Kubernetes deployment?
Yes, we have a Kubernetes operator and a Kubernetes quick start guide on our website. Great.
And I can add to that, we have tested it and it works. So it was fairly easy to set up. Let's see, you've got one here. What feature should I show? This is on the Q&A. What feature should I show to convince someone to use RedPanda over Kafka?
Probably the setup. So one of the things that we actually found very fascinating is that a lot of people came to us first because of they're using RedPanda in their continuous integration, continuous deployment pipelines. Because one example is one customer actually removed Kafka and replaced it with RedPanda for their CI/CD framework pipelines, and that pipeline went from 15 minutes down to 5 minutes because they didn't have the startup times for Kafka and things from that perspective. So I'd say the operational ease of use is huge, and then the performance is dramatic. I mean, just one anecdote really quickly is that one user actually tried out RedPanda really in the about a year or so ago, where they were able to replace 300 nodes of Kafka with 3 nodes of RedPanda. And the 300 nodes of Kafka was 16 core boxes, and the 3 nodes of RedPanda were 96 core boxes, but still a pretty dramatic reduction in hardware to be able to do the same exact workload between the 2 different clusters.
I'm muted. Great. I'm just looking here to see if we have any other questions. I think you've nailed the questions on the Q&A. Thank you very much. We got the questions on the stream. So if anybody else has questions or wants to go ahead and post them either in chat and Q&A. Rocco, will you stick around for a bit in case more things come up?
Sure, absolutely. Be happy to.
Okay, wonderful. Thank you so much for an awesome talk. Yeah, and I'll just say that we're looking forward at Altinity working with RedPanda. We're already trying it out. It's gotten rave reviews from some of our customers. So definitely some cool technology, and we're looking forward to building stuff with it. All right,
Robert, appreciate it.
You're most welcome. Great. I'm going to go ahead and kick off the next talk, and that's going to be me and my colleague, Graham Mannering. And rather than give ourselves an introduction, I'll just start the talk. So give me 1 second here. Oh, here's one. While we're coming up, we've got another question from Gilad. If you want to go ahead and answer that, I'll go ahead and do our screen share and get our stuff going.
Yeah, so using RedPanda as a backup or kind of a silver layer for petabytes of data. Yeah, absolutely. That's really why we built shadow indexing, is that we have one customer that wants to store 7 years worth of data, which is huge amounts. But yes, and then we also have another customer where they're doing exactly kind of what I showed, where they're rehydrating parts of their ClickHouse stream or their ClickHouse database from a longer term storage of data that's inside of RedPanda itself.
Okay, thanks. So with that, I think we've finished the RedPanda presentation. I'm going to pause for 1 second because it's going to make me easier to cut the video. Okay, let's dive into our next talk. So Graham and I are going to talk about data warehouses in Kubernetes visualized, introducing the ClickHouse Kubernetes Operator UI. So this is something that that we've been beavering away at for a few months. And so in this talk, I'm going to do the front part and talk about just ClickHouse on Kubernetes, how it works, how the operator works, and then we'll dive in and show the UI, which is something you can actually try out at the end of this meeting, because we'll include the URLs. So let's just jump in a little bit about us. So Graham, my colleague, is a senior cloud engineer. He has been working in enterprise software for 25 years. Most recently, one of his recent gigs was at Red Hat, where he was working on Ansible, and in particular was working on the Ansible Receptor project, which is used for remote commands, dispatching remote commands for Ansible. I'm a database geek. I run Altinity, but more importantly, I've been working on databases since 1983, so it's a long time. And ClickHouse is database number 20, and definitely in my top 2 of favorites. The other one is Sybase, in case you're curious. So a little bit about Altinity. We do support and services for ClickHouse. We have, at this point, I think, well, I haven't looked recently, but something like 160, 170 subscription customers. It's a lot, and including a pretty good chunk of them on the cloud. We also do training. We do feature engineering. We do builds for ClickHouse. Just a bunch of stuff. Anything that makes people successful at building applications that do real-time analytics based on ClickHouse. For this talk, what's significant is that we wrote the ClickHouse operator. This is something we've been working on for 3 years. It's the basis of our cloud system, of Altinity.cloud. And what we'll be showing you in this is the most recent advance, which is to stick a UI on top of it. So let me just check that things are okay. Everything looks good on the recording. What I'm going to do is back off a little bit because I'm not going to assume that everybody here knows what Kubernetes is. So I'm going to have a little intro to it. I hope you won't find it boring if you're a Kubernetes person. And then what I'll do is I'll show how the operator works. But it's all going to be batch, and then we'll turn it over to Graham to talk about to show the new UI. So Kubernetes is sometimes called the new Linux, which is, you know how it is when people write articles, they need to have some catchy phrase. And in a way, it's, I guess you could say that it's where your applications run, but it's not an operating system. What it is, most importantly, is it's an orchestration system for container-based applications. So containers being Docker or a host of other types of packaging that basically function the same way. So that's what it does first and foremost, but it does some other things which are really important. Second is it represents a form of infrastructure as code, where you can give a definition of something in a code-like representation, in this case YAML, and ClickHouse will look at, or excuse me, Kubernetes will look at it and make it be so, and we'll see an example of that. So you can basically program the system very efficiently. It's also an awesome cluster manager. And this is important because if you have a stack of hardware, or for example, even a cloud environment, and you want to make sure that it's fully utilized, or that as you need new capacity, it's automatically added and your applications get fair access to it, Kubernetes takes care of that. So in many ways, it has some of the properties that we traditionally have thought of as being handled by private clouds like VMware or Nutanix, where it basically ensures that you get a distribution of resources in some reasonable way across a set of underlying resources or underlying infrastructure. And finally, it's a pretty common endpoint for CI/CD automation. So because you can work through APIs, you can basically have CI/CD pipelines that will deploy applications, and at the end of one of your pipelines, you can basically have things plop out. You can basically sort of execute or deliver files to Kubernetes, and then basically set things up in your Kubernetes cluster. So this Marvel runs in it's one sort of huge set of combined, sort of cooperating, if you will, open source projects. So it's underlying open source. It runs in a huge number of environments. I run Minikube pretty heavily on my own servers. There's also K8s. That's another one. So there's a number of development or IoT sized versions of this. There's also what we call self-managed Kubernetes, things like Kops and Rancher that allow you to bring up these clusters on your own hardware, or sort of an allocated set of VMs. And then finally, over the last few years, there's been a really prominent development in which all of the cloud vendors, actually large and small, are now introducing managed Kubernetes. For example, Amazon EKS that stands up Kubernetes, takes care of most of the dirty work of running the infrastructure for you, and you pay $70 a month, something like that, and then you can have clusters as large as you want. So this is very popular in the public cloud, both for users because it's a good deal to get this managed for you, and also for people like Amazon and Google because it helps them sell you infrastructure. So here's how it works. If you haven't seen it before, basically you have applications and they consist of resources, and we'll talk a little bit about what those resources are. But the basic idea is if you define an application as a set of resources, Kubernetes will then take care of mapping it to the underlying hardware. So for example, you can think of that as physical nodes. These could be VMs with, for example, with local storage, or you could have, you could be looking at block storage here, but basically you have some underlying infrastructure that you would normally set up with Ansible, or maybe you would just log in and run scripts. Kubernetes takes care of taking your application definitions and mapping them in to the physical infrastructure. So here's an example of a distributed application. This looks amazingly like Zookeeper, actually, where you might have 3 Zookeeper processes. Those are the orange things. They each have local storage. Now they talk to each other because they have a network connecting them. And when people come into Zookeeper, it's kind of nice if there's a load balancer, so they don't have to remember where the actual IPs are and which ones are available and which ones are not. They just come to the load balancer and it finds a Zookeeper process automatically. So this would be the application. And when we translate this to Kubernetes, what we're going to do is define it in terms of Kubernetes resources. So we will have what's called well, let's start at the top. Coming in from the entrance, we'll have the service. That's actually a load balancer. So that's a resource that represents that represents some load balancer implementation, which Kubernetes will provide for you. You then have pods. Pods are basically processes. These are Docker containers if you're using Docker, which basically means they're isolated processes, or more or less isolated processes. We're using C groups, we're using overlay FS, we're using namespaces so that they run basically in their own little environments and more or less can't see each other. They can be combined together into something called a stateful set. A stateful set is a way of grouping these pods together, and you can say things like, hey, I want to have 3 pods, and by the way, these things will have predictable names, and they will also have what are called storage claims or volume claims, which allow them to then allocate storage, and then if the pod changes or goes away or gets restarted, to find it again. So the stateful set understands that it gives the pods standard names and knows how to connect them up to their volume claims. And the volume claim is just a resource that says, hey, I want X amount of storage. I want 100 gigs of storage of a certain type. You put this volume claim in, and then what Kubernetes will do is it will actually go allocate storage somewhere for you using a storage class, which is a thing that can allocate it. And then finally, you have things like config maps, which are variables, think parameters that you need to feed to the application. For example, if you were doing the thing we looked at the previous talk, where you have an event stream like RedPanda talking to ClickHouse, each of these is going to have to be parameterized so that ClickHouse, for example, knows where RedPanda is. So that's something you could pass in. That's a variable you could pass in a config map. So this is basically what Kubernetes looks like, and it's kind of complicated if you haven't seen it before. But I think the aha experience for me at least is that what Kubernetes really does is these resource definitions are the parts of a distributed application. So if you start to think about yourself or your application as not being, like a specific program, but to think of it as a distributed application, which needs to have configuration information, which needs load balancers, which has a notion of separate processes running on separate nodes, has attached storage. Kubernetes resources just allow you to now define these distributed applications, and then by putting the definitions of these resources in, Kubernetes just makes it happen out on the infrastructure. Okay, so much for theory. We want to get ClickHouse to work in this scheme, and the problem that we run into is that ClickHouse is pretty complex. It's okay if you just have one ClickHouse, but that's pretty rare in production systems. You'll normally have at least a couple so that you can use replication to make sure that the ClickHouse servers stay available. And if one of them gets killed or loses its mind, loses storage, you have other replicas that you can refer to. Larger system, of course, you'll tend to have shards. And so you'll split the data into disjoint sets. If you map all of this stuff to, for each of these servers to, if you map that to the Kubernetes resources, it's horrendously complex. It's just a bunch of resources that get repeated again and again and again. And then as you upgrade or as you decide to change the size of nodes, like the amount of memory, CPU, storage that you make available to them, the number of storage nodes, it becomes very, very difficult to maintain. On top of that, ClickHouse needs to talk to things like Kubernetes. So this, if we just did this by hand or even used tools like Helm charts, which is basically a templating mechanism, it would be very, very hard to make this work. So fortunately, Kubernetes has an answer to this. It's called a Kubernetes operator. And what it does is it allows you to define new kinds of resources. So the resource in this particular case is a ClickHouse installation. We call it a CHI, a ClickHouse installation. And what you can do is you can basically have a YAML file which defines what you'd like this resource to look like. And you put in all the information that's necessary to define what your cluster should look like. You then upload it or apply it to Kubernetes. So you take this YAML file and you run a command called kubectl-f, apply, and you then hand it to Kubernetes. Kubernetes will look up the type of resource you have, and then it will say, aha, this belongs to the ClickHouse operator or whatever operator that resource that is responsible for managing that. And then that operator is going to look at this resource definition, and it's going to look at what's available inside Kubernetes. And it's basically going to adjust the Kubernetes reality to match your code. So, that is how that's how this works. And then in the end, one of the things that's cool about this is the operator takes care of setting up your application in what we call a best practice deployment. This is ideally because the operator knows how your application should be set up and can take this relatively simple definition of what you want and then turn it into these very complex resources for ClickHouse. Moreover, as your definition changes, it will then go ahead and readjust reality so that your cluster on Kubernetes continues to have the properties that you want. So I hope that makes sense. For those of you who haven't worked with Kubernetes, operators are just this huge step forward, and it basically allows the capabilities I just described allow you to run databases on Kubernetes. And it's not just we wrote the ClickHouse operator, but just about every database worthy of the name has an operator now, and that functions in this way. So what I'm going to talk about next is how to create a cluster on Kubernetes using the ClickHouse operator. So this will give you a sense of how it works and walk you through an example. It's all command line driven. So so we'll start, because that's kind of the current way that you manage this. And what we'll do is there's a few simple steps when you're using operators. You first of all have to install the operator itself. It's distributed as a container, and this shows the commands. These are what we're doing is pulling from our GitHub repo a YAML file that contains all the configuration information for the operator, which and there's a number of files. There's a number of different types of things. There's several types of resources that define the resources that we're going to be managing. There's another resource that defines where to find the operator itself. Some more stuff related to security. It's all stuck in one YAML file. And all you do is you grab that YAML file and then you say kubectl apply -f, give the name of the file. And what that will do is it will start the operator as a Kubernetes application by default in the kube system namespace. That's where system software lives in Kubernetes. And at that point, you have an operator. In this presentation, I have some stuff marked in red. These are things to note. They are health and safety advice and just things that you ought not to do, because if you do, bad things will happen. So for example, if you're a Kubernetes person, you'll say, oh, like if I can apply it, well, then if I want to take it away, I should delete it. That's a standard. Those two verbs are kind of mirror images of each other. One thing that's important to note with operators is you want to be very wary of taking them away when you've got live clusters, because what deleting this file will take away the resource definitions. If you do that, Kubernetes will say, hey, I've got resources I no longer know about, and it will go ahead and delete them. So this is an error you don't want to make. So this is true, this is not just something specific to our operator, it's something that's just generally true in Kubernetes. That gets you the operator. You need to have Zookeeper. We don't do anything special to manage it. We have some scripts in our GitHub repo, which can allow you to set up Zookeepers. Here's an example. This is a dev test one. Again, there's a health and safety note here. It's going to, and the reason the health thing here is it's only one Kubernetes, only one Zookeeper instance. You run these commands, and then you'll have Zookeeper. So, and it's going to be stuck in a namespace called zoo1ns. And what that means is, as we'll see, Kubernetes creates DNS names using the namespace dot and then whatever the name of the pod is, if you want to go find it, or the load balancer. So these two commands, or three commands, if you will, get you Zookeeper up and running. Once those are running, you can bring up a data warehouse that actually does some fun things like sharding and replication. And so what we're going to do is we're going to create a file called first.yaml, and we're going to apply it. This is the only command that you need to bring up as big a ClickHouse cluster as you could possibly wish to have. But the point is that you need to put some stuff in that file. So what I'm going to do in the next 4 slides is I'll show you the parts. And so first, this is all one YAML file. I'm just scrolling through it. The first thing is the basics. So what kind of resource are we describing? ClickHouse installation. This is what Kubernetes uses to decide which of the operators should get to look at this and actually do something with it. Then we have things like the name, and then we have the configuration of the actual clusters. So things like, and this is where you can start to see some of the power here, because we simply, if we want 2 shards, we just say shards count 2. If we want each of those shards to have 2 replicas, we say replicas counts 2. If we want to define what the pods look like, we can just use a template. I'll show you what it looks like in a second. We're using one called ClickHouse Stable for the pod template, and then we have to have a template to define our storage. And then we have a clause which says, hey, where Zookeeper live? There it is. So this is referring to the load balancer that's in front of our one Zookeeper node. And with that, we've got the basic information necessary that defines the ClickHouse topology. Next thing, it's nice to have users in databases. You don't always want to use default and with no password as your user. So this shows an example in the next part of the file where we define a user called demo with password top secret. So this is a standard. If you're familiar with ClickHouse, you'll recognize that this actually looks an awful lot like the XML tags just expressed in YAML. That's exactly what it is. So a tag demo password SHA-256 that defines the user with this password, and then gives it a profile and quota and sets up some IP masks. In this case, we're being pretty liberal and saying, hey, we'll take connections from anywhere. So third thing, let's define what the pods are. So what servers do we want to run? In this particular case, what we're going to do is we're going to, for the ClickHouse container, we're going to run an Altinity stable release. These are ClickHouse builds, fully open source. This is based on 21.8.10.1, and these are just, they have long, basically this has 3 years of maintenance on it. So we're just going to say, hey, we're going to use this build. And then there's a couple other important things with when you're talking about servers. It's kind of nice if they don't all somehow cluster on the same machine. If you leave Kubernetes to its own devices, it will happily just, wherever it finds memory, it will, available memory and a CPU, and where it can allocate the storage, the first machine it finds, or some random machine, it will just pick it and stick the pod there. If it happens that all the pods fit onto, the pods are small enough that they can fit onto one big machine, there's a reasonable chance that sooner or later they'll all end up on the same machine. So if that dies, your cluster dies. What this does here, this pod distribution, is it applies a property called anti-affinity, and it says, hey, every pod's got to go on a separate Kubernetes node. That splits them out. So if you lose a node, you're only going to lose one replica. So again, a health and safety warning. We always recommend doing this for real systems. Final thing, storage. Well, actually, there's a health and safety warning up here, which is to ensure your storage is persistent. I think Graham will show an example where it's not. That's bad, and it's true. It's double bad because not only will it fail, but it will. What's even worse, it'll run for a while before it fails, and you may not realize that that you don't have storage, because ClickHouse has replication. As long as you only lose pods one at a time, they'll come back up and they'll happily replicate back. They can end up replicating, sort of continuing to pick up data, and you can have cases where you don't realize you don't have storage. So, ensuring that you have persistent storage is really important. And then there's a tag here called retain, which says, hey, if we delete the installation, don't delete our volume claims with it. That's pretty important, because it means if you accidentally kill delete this whole cluster, we don't want our storage to go away. And what will happen in this case, if you delete the cluster and remake it, when you restart it, it will come back and it'll find the original storage and reattach to it, which is pretty cool. The other things are pretty standard. If you're familiar with Kubernetes, asking for 100 gigs of what's called premium RWO. This is high performance SSD in Google Cloud. So that's it. We put these, we have this all in one file. We applied it. Kubernetes comes up and it runs. So, and then once it comes up, we actually want to go ahead and do a few checks to make sure it's alive. So I always do safety checks, make sure I really have storage. So we can list our persistent volume claims. We can make sure pods are on separate nodes. This is some kubectl magic to give a list of your pods and show which node, which VM or host they're on. And then finally, you want to just go check to see whether we can get in and actually, so we can exec into the pod. It's just same thing that Docker allows you to do, and then we can run the ClickHouse client and test that our user demo and its password secret works. So this is it. This is created a cluster. We can go ahead and change that file and resubmit it, and then the operator will automatically change the cluster to match it. It brings up a question. This is a lot of code and it's a lot of steps. So the question is, wouldn't it be better if we just had a UI for this? And particularly if you're a dev and you want to set this stuff up, yeah, you can go read our documentation. you can figure out how to do it. You can go find one of like an Altinity video or something like that. But in the grand scheme of things, particularly for development, people just use UIs for this stuff. So that brings us to the next part of this talk, which is to introduce the Altinity dashboard. And for that, Graham, I'm going to turn it over to you and flip up your first slide.
Sure, thanks. Can everybody hear me?
Perfectly.
All right. So thanks for that that fairly comprehensive review of how the operator works. I don't know about anybody else, but as you were talking, I forgot half of it in the last minute. And by tomorrow, I won't remember any of it. So the idea with having a dashboard and a UI is that you don't have to remember all that stuff. You can just fire it up and click a few mouse clicks and make things happen. So that's the basic goal. We want to make it as easy as possible if you have Kubernetes up and running to deploy ClickHouse into it, to see what's going on with your ClickHouse deployment and to be able to see it in a nice, simple view that doesn't have a lot of extraneous information. You could use overall Kubernetes the Kubernetes dashboard product or Lens or something like that. But we wanted to provide something where you only see the things that actually matter to ClickHouse, and where we have the opportunity to give you warnings and kind of guide you through the steps, rather than just doing kind of anything, unbounded like you would in Lens or Dashboard. So I'm going to share my screen here. Oh, actually, Robert, can you? There we go.
You should be free to demo.
All right, so hopefully people are seeing this. This is the GitHub page for the Altinity dashboard project. This is open source. It's at a fairly early stage of development. We've got a bunch of open issues, and not all of the functionality that we want in here is written yet, but it's kind of at a point of critical mass where we thought it was good enough to let people see it. If you want to just download and run it, we have GitHub releases. These are single file static Go binaries, so you just download the appropriate one for your platform and run it. And that looks like this. So what I'm running against here is a freshly installed Minikube Kubernetes. You call it a cluster, but it has one node. There's nothing in it. It doesn't have the operator deployed. It doesn't have any ClickHouse deployed. So if I look at the operators list, I see it's empty. If I look at the list of ClickHouse installations, it gives me an error because it doesn't have the resource definition for ClickHouse defined in Kubernetes. So I want to deploy an operator, click the little plus sign. By default, it's going to give me the latest version, and I'm going to put the operator in kube system, which for small, for Minikube type deployments, that's pretty much where operators go. And we can see that it's now pulling the image for it. And it's running. So that wasn't very painful. Now over here, we no longer have the error message because we have the CRD, and we have the ability to deploy ClickHouse itself. This uses a YAML file like Robert was describing. We can't really get away from the YAML file because the number of options to configure is large enough that building a UI for it isn't really feasible. But we did build in the examples from the docs, so you can just pull them straight up. Let me add a user. And instead of QWERTY, I'm going to do a hashed password, and the UI has the ability to create a hash for me. So this is the minimum possible amount of configuration to get any ClickHouse at all running. It's not going to have storage behind it. It's going to have a single shard, single replica, and it's just going to have one user. So we'll go ahead and deploy this. Did someone have a question?
I think we're getting some background noise here.
Gotcha. Okay. So we can see that this is in progress, meaning the operator is doing something. What it's doing is deploying these containers, pods. We just finished pulling the image, and now it's started running, and in a minute it'll go from in progress to completed. You'll notice that the name of the cluster just became a clickable link. If I click on it, I get to the web UI of ClickHouse itself, which if you've used it before, you'll be familiar with. And I can run some query. So that's all it took to get from 0 to being able to run queries against ClickHouse. Obviously, I'm not happy about the fact that I have no storage configured, and this is only a single replica, single shard. So I have a YAML file here. Oh, no, that's the wrong file. Okay, maybe I don't have. There it is. Yeah, that's the file that I wanted. So this, let me update the password again. Sorry, live demos, you know. So this has, just to make it interesting, let's give it 2 shards, 2 replicas. And it has real storage, volume claim template. It's asking for 1 gig of a storage class called standard on Minikube. That's the only storage class that we have. So I'm going to go ahead and deploy this, and it's called simple with storage 01. That's fine. We can watch this deploy pods one at a time. Within each pod, we can see the container, and we can also see the storage configuration. So we can see that this has created a persistent volume claim and that it's bound to an actual persistent volume. As these containers come up, it should launch the second node and the third and the fourth. I'm not quite sure how long that's going to take, but I think it should already be, no, maybe not quite. Jump the gun there. There we go, cluster number, pod number 2. And it's usable. So if I get tired of my ClickHouse installation and I don't want it anymore, I can delete one. In this case, I'm deleting all the data because there's no persistent storage. I can go to edit, and I get back the current YAML of the running installation. I can edit this. I could change the number of replicas or shards, and the operator would then act to bring reality back in line with what the YAML file says it should be. So that's basically it.
Great. And this is, we've been playing around with this for, I don't know, I think you and I have been working on this for about a month at this point, Graham.
Yeah, about that.
Yeah, it's and as Graham said, there's definitely lots more to do, but we think this is at a state where we're having fun with it, so we want to put it out there and make it available to everyone else. Let me just, so I'm going to go ahead and Graham, I'm going to get back to my share.
Yeah.
And let's see if I can go ahead and get that back up again. Great. Let me know when you can see that.
Yeah, we got it.
Okay, great. So caveats. Yeah. So Graham, I think you would agree with all of these, correct?
Yes, absolutely. We've got an issue queue with several of the features that we're interested in listed in it. And we're also very interested in if anybody tries it out and says, oh, I wish I could do this. We'd love to hear about it.
Yeah. A big priority for us is, I think some of those health and safety warnings that I described in the talk, we definitely want this tool to be able to tell you that you're safe. You know, so remember the old Marathon Man movie, Is It Safe? This is something that we all want to know, because with Kubernetes, it's very easy to bring up data. But it is here's a great one. Rescaling storage. I wonder if that works on Minikube. We could try it. We've got a question coming in from YouTube. Can you demo how to rescale your storage from 1 gigs to 2 gigs? I failed to rescale the storage in AKS. We could try it. Maybe what I'll do is run the rest of the slides, and then we can. Graham, is that something you'd like to try to see if it works?
Yeah, I'm curious myself what might happen.
Yeah, so great question. Okay, hold that thought, and we're going to go try a rescale here. We may have to. It may not work in Minikube because of the way it allocates storage. So yeah, log issues. There's also the Altinity DB Slack. When these slides come out, they'll have links to them. But you can log an issue on the project. The dashboard itself is an open source project. We just open sourced it, I think, about 2 hours ago, something like that. Not much more. So it's pretty fresh. There's of course the Kubernetes operator. These are all links, and I'll show you the full URLs in the next screen. There's the Altinity documentation. Of course, there's ClickHouse. That should be a link to the ClickHouse project, and then the Altinity blog. We'll do a blog article in the next couple days to describe how this works, to talk about the workflow. But we thought it'd be more fun to just show it, and then we'll do a nice blog, so you can probably see that early next week. In the meantime, if you bring it up, if you know the operator, it doesn't require much documentation. It's pretty obvious how it works. So, I see a question coming up about Helm charts. I will get to that in a minute. That is a really great one. So we're at the end of the talk. Thank you. We're hiring. If you know Kubernetes, if you like ClickHouse, if you like data, actually the biggest thing we're hiring is we're trying to find a dev advocate. If we can't find one by the end of, if we can't find a dev advocate by the end of this month, I have to dye my hair purple. So it's not looking real good right now. If you can help us with that, that'd be great. Here are the projects. So the full URLs, really just, if you Google GitHub Altinity ClickHouse Operator or GitHub Altinity dashboard, that one you might not find so quickly because it's just been up for a couple hours. But that's basically how you can find these. So we have a number of questions. Graham, I'm going to unshare. If you want to try rescaling the storage, that would be totally cool.
Okay.
Yeah, and then so this is for Boyu, and yeah, let's see what happens. Okay, I'm going to bet that this will work. I'm going to bet this will work, but I think because of the way Minikube allocates storage, I think ClickHouse will lose its mind.
Yeah, I don't know that Minikube is going to give it back a PV that has the same data in it.
Exactly. Yeah, that would be the test, is to see whether you still have tables in it after it gets done.
Yeah, one of the features we'd really like is to have more communication between the UI and the guts of the operator, so that we could see something up here about what it's doing rather than just in progress. But my guess is the operator is probably trying and failing to replace this volume, and it can't because it's in use.
Right. Yeah, I think that we do know that this rescale works on, if you're using if you're using, for example, EKS, rescale works fine. We do it a lot with block storage, actually, and it's a feature of our cloud. So I know it works, but we probably need to. It's a great question. I think what we can do is provide some tips on how to do a rescale. And in fact,
maybe we need some custom knowledge within the dashboard about how to do that successfully.
Yeah. Yep. Another thing, there was another question. Yeah, so this was about volume rescaling in AKS. I assume that's Azure Kubernetes, managed Kubernetes. I actually don't know about doing it there. I've never used AKS. I see. So we have a comment from Denise that resize works in Oz and Google Cloud, but it's an issue in Azure. So a question from Jonas on coming off the stream. This is a great one. It is. I was wondering why there is no Helm chart available for installing the ClickHouse operator. It's a great question, and the reason is really simple. We didn't think it was necessary, and we were completely wrong. We've had that request from a number of people, so we're planning to build a Helm chart. We don't have it yet. Actually, if somebody wanted to make one, we wouldn't refuse the help, but it's definitely something that we'll be doing. So great question, and what will happen is you'll have a Helm chart that will just install the operator for you, and possibly another Helm chart that would install this A-dash. That's another thing that could be Helm charted. So here's a question, Boyu. I noticed that the statement is gone. It doesn't mean it is now production ready. What is the criteria for production ready? I think that this is, I believe this is referring to the operator, whether it is production ready. The answer is yes. We use it for Altinity.cloud. We have about 100 clusters running on it right now, or it's used in at least 100 clusters at this point, more, and more coming on every day. We also have a bunch of customers who aren't running on Kubernetes, and sort of community users who are using it. Like, for example, Mux uses it, eBay uses it. It's very widely used at this point. So definitely would not hesitate to use it at this point. What we are doing with the operator is we're putting more effort into documenting it. I think the documentation was a little bit, shall we say, open sourcey. So we're trying to build that out. We're putting more testing to ensure it's bomb proof. And of course, this UI is part of just making it easier to use. So, all right, we have, what will oh, here's a great question. I love this one from Gilad. What will happen to a replicated merge tree when adding to one to the replication value? In other words, if you go from 1 to 2 replicas, we will automatically copy the schema across. It will come up and just pick up the data. So that's actually a key thing that the replicator does, is the operator is it does basic schema management, that when you bring up new replicas, it'll basically look at the replication setting that you have. And if a table is meant to be replicated, either because it's a replica on a shard or because it's being replicated to every single server, the operator will ensure the schema is put in for you. Another question, when will a link to the current meetup be available? It will, you can actually, if you want to see this recording, you can go ahead and look at on our YouTube channel that this live stream will be available. We will publish a blog article next week with slides from all our presentations, including Rocco's great presentation, and then we'll go ahead and let's see. Oh, I love this next question. At this point, let me ask, are there any more questions about the operator? Because if not, we'll just open it up, and any question you want to ask, we'll take them. So any more questions about this talk? Okay, if not, Graham, thank you so much for putting this UI together. I think, as you know, it saved my life the first time I brought it up.
I think Ramazan had a question of what happens when you increase the shards.
Oh, yes.
What will
Okay.
happen to existing data?
Oh, that's was it that the one from Gilad, or where?
No, that's in the chat instead of the Q&A.
Ramazan, I'm so sorry. Here, let me. What will happen? Oh, that's a great question, Ramazan. Thank you so much. What will happen is we'll add the schema, but we won't move any data. That's a really great question. And the reason is that ClickHouse does not know how to rebalance shard data. It is a very hot topic in the community, among the core committers. But we're sort of dependent on ClickHouse knowing how to move stuff around, and right now it doesn't. So that's a key thing. When you add shards, yes, we make it easy, but we don't move your data for you. We are looking at some ways to make this happen. Like other people. Is there some sort of tool to rebalance data? Right now, it's pretty weak. Tatiana, if you're still on, do you have any suggestions for rebalancing? I know this is something that comes up a lot.
Yeah, there is a tool that lets you just reinsert your data, or otherwise you can move like files manually. There are some commands in ClickHouse that can help with that, but that's really just the two ways that you have. You either move the files or reinsert the data.
Right. It's a place where it's one of the places where ClickHouse needs some help. So thanks, Ramazan, for that question. It's a great one. Yeah. So.
Yeah, insert select. Yeah.
Insert select will do it. There's various ways you can move parts across. I think that's probably the most common way or one of the common ways. But there's various commands to do it, but it's not. There's no magic. You're doing it yourself. Okay, with that, I'm going to open it up to any question anybody wants to ask. And the first one, I love this question. Non-related question: will Altinity create an M1 Docker image? Well, the answer is yes, we've already created it. So it's actually out on our, let me tell you what's going on here. Since you guys are here and listening, we can give you a few. Here's an interesting one. I will come back to this. So there's a thing from Ryan that goes back to this talk. So there's two things going on with Mac. First, we are building ARM containers. We just did a blog article because we're using them on Graviton right now. The state of ARM is the following. The Docker containers are the ARM builds. We're doing native ARM builds. So we started doing those a little while ago. We still regard them as experimental. There are a few issues. For example, there have been some issues where we're seeing test failures. We're investigating what's going on there. It may be because we don't know what the root cause is. There's a few of these, but anyway, yes, the ARM builds exist. We're going to actually distribute them. Make them. I mean, you can pull the experimental versions off our Docker Hub. They have kind of odd tag names, and try them. But as soon as we can, we'll get these out and available to people. So yes, that's happening. Second thing, and this is more going to come out, I hope, this month. We've got brew support. So if you're running, if you use brew and want to have something actually just installed on the operating system, we have that working now. It works for both M1 as well as Intel AMD. well, not AMD wouldn't be relevant here. Sorry. And so we'll be publishing a blog article on that shortly to show how you can use brew install to get ClickHouse client or ClickHouse, actually the whole kit and caboodle just installed natively on your Mac. So yeah, big yes on that. We're working on it. It's there's about half the team is geeking out on ARM processors right now, so this stuff is coming. Yeah, so does ARM ClickHouse have a performance deduction due to missing inter-array operations? The answer is yes. There are two libraries that are not supported on ARM. I don't have them in front of me, but one of them is actually SIMD enabled operations on strings. So yeah, okay, Gilad likes the brew thing. That's awesome. We're glad to hear that. So yeah, there's this one library which is, I think, produced by Intel, so obviously it uses Intel SIMD instructions. It's not available on ARM. That means some string functions are slower. We have another question coming back, wasn't signed in before. My team has a Helm chart working similar to the Prometheus operator, so it handles our deploy of both the operator and sets up the CRDs for us. Is this similar to how your Helm chart would be set up? The answer is yes. It would basically just deploy the operator. And we're, we'll have to look at what's the best way to do it. The key thing is to have Helm, not take away the CRDs by accident. That's, again, something we're very paranoid about, that because it'll kill your clusters. So, okay, so I'm looking at Ryan's messages on YouTube. Okay, yeah, I think this is something we haven't looked at it, is really the answer, but we will do so. We know other people who've done similar things. If you want to send it, basically send your, contact us at info@altinity.com or log an issue. We'd be happy to work with you on that and get something that works. This is definitely on our roadmap. Let's see, other questions. Oh, here's a good one, kind of non-technical. ClickHouse has been incorporated since last September. What is Altinity's relationship with that new company? Very simple. We collaborate on a daily basis on the open source. We've known the committers at Yandex for many years at this point. We're good friends with Alexi. So as far as open source collaboration is concerned, there's no change. I would say that we're competitors, except that ClickHouse doesn't have a product yet. I'm sure they will soon, and it'll probably be quite a good one. So we will see at that point. But at this point, I think we're both working in the same market. We have different takes on what is what is important. What you'll see with ClickHouse, I believe, and I don't want to speak for them, but this is what they've said publicly, is that they are very focused on building a cloud service akin to Snowflake. I think that's sort of the model that you could expect. We have a different view of the market. We enable people to run ClickHouse anywhere, both by enabling portability and ensuring that ClickHouse is permissively licensed under, and all of the components that are necessary to run it are permissively licensed. So it's kind of different takes on this market. I think over time, you will see a continued explosion of offerings in this marketplace. As more people come in and build services based on ClickHouse. I just learned of another one a couple of days ago. We'll be commenting about on our blog, a very, very interesting competitor that has integrated, is using ClickHouse as a query engine now. So you're going to see a lot of stuff in the market. So I hope that Jay, I hope that answers the question. But we see ourselves as basically being in the market and offering somewhat different things, to some overlap, but also some things that are different. Let's see.
Thank you.
You're welcome. Question here. I'm planning to create a cluster for big clients and a cluster for small clients. Is it better to implement as a shard per client? size, and then using a bi-level shard key. Tatiana, if you can see this question, this is one that sounds like you might have some advice on.
Well, I think that it's better to keep your system as simple as possible for as long as possible. So if you can have just maybe different shards for different clients, maybe like group different clients and by some rules, but the two-level sharding system is not very easy to deal with, to manage, and your application has to be aware of the rules that you used to split the data. So yeah, I would try to keep the system one level if it's possible.
Yeah, I would agree with that. One, because one of the things that is, I mean, I think it's okay to have different if, as it were, to have different groups of clients. But one of the problems you have is that tenants have a tendency to grow, and you can't, you can have a small tenant and then they can become a big tenant. And what do you do? So that is, I think that becomes an issue. Tatiana, it feels like I think the place where we see some of the most trickiest problems are around, sort of privacy related things, where somebody has a bunch of tenants mixed into a single schema and they need to get rid of one of them. Or they need to trim some of the tenant data to remove users. This is driven by GDPR and various other types of privacy regulations. That's actually where we see issues. It's not so much where to put tenants in the first place when they're accumulating data. I don't know what your experience has been, but those are the questions that I see coming up. Okay. Did I miss any questions? I'm just looking here. So here's a great question, Gilad. Does not alter delete help with the issues? Gilad, I'm going to go ahead and you can go ahead and talk. Let's see. Gilad. You can unmute if you want. If you want to continue. So yeah, alter delete does help, but actually what we're doing right now is we're implementing a true SQL delete. We call it lightweight delete. We hope there'll be an MVP available end of this year, but it's getting kind of late, and something that's usable that people can begin to try out in a couple of months. So, and the idea here is that you'll delete a row, you'll delete some number of rows based on a query, just like you do in real SQL. We'll have a bit mask, which basically masks those rows. It kind of works like a tombstone, and that row will no longer appear, and then it'll get garbage collected at some point. But we have to we'll have to remerge the part to get that to happen. All right. I'd like to, yeah. Go ahead.
Solution. It's close to the solution of the collapsing or another type of merge tree, but with masking.
Right. And so we've been working on it for a while. It's tricky to get adequate performance, but this is one that Altinity has responsibility for in the roadmap. And I want to say we've gotten some really good help from from Alexei Milovidov and other folks on his team. So I'm hopeful we'll be able to show everybody something in the not too distant future.
Nice. I like your job a lot.
We like it too. Any other questions? We're happy to answer. We're coming up on 2. That's the end. If there's another question, otherwise we'll call it a day.
Pretty much female question is too personal to me, so not everyone should listen to this.
Feel free to contact us directly if you have additional questions.
Okay, thank you.
I want to thank our presenters again. I know that I think Rocco dropped off, but RedPanda did a great job. We love what they're doing. From Ramzan, what happened to the materialized presentation? That's at the next. We hope to have that at the next meetup. I met one of the dev advocate for Materialize. Their stuff is cool. It's sufficiently similar to what we do with Materialize using ClickHouse. So I think it'd be really cool to hear about how it works. And then we can get ideas for making ClickHouse better.
I have another question.
Please.
If I do a shard per tenant, I may have thousands of shards.
Right.
And then I want to add a replica. Will it add thousands of replicas?
Yes. Well, yeah, no, actually, it's assuming if you had a shard per tenant, you could then, I mean, you can have differing numbers of replicas in each shard. There's nothing that stops you from doing it. But I don't think, because it's a matter of where you set up the replicated merge tree tables, right? But I don't think you'd want to do that because that system, as Tatiana said, it would become very complicated. And with ClickHouse, complicated is bad. It's better to have, you know, because you also have the problem that the big problem we see is that when people get into that, you're also talking about these shards now having to be, you know, on separate hosts, you know, managing, you know, remote servers.xml. The fact that shards become bigger and smaller, and then shards are, you know, you then have problems load balancing across hosts, since ClickHouse doesn't move data automatically. So I would be very leery of having a shard per tenant. I think it will cause a lot of problems.
Okay. Is there a template for one shard that like one shard that in your webinar about strong in numbers, you mentioned that you achieved almost linear performance when adding more nodes of ClickHouse.
Right.
So I tried to replicate it, but I didn't understand fully how to do it because of the configuration of sharding or configuration of.
What I did I remember that. So I had 1, 2, and 4 shards. The way that I did that was I basically had one cluster with like a single shard. I had another cluster with 2. I had another cluster with 4. And then I loaded them through a distributed table, which would then load balance, insert the data. And I think I use RAND as the shard key. As a result, it just partitioned the data automatically, or sharded the data automatically out to the and then the demonstration is okay. Then when you run the cluster, as long as it's nicely balanced, you get exactly linear. You get exactly linear scaling. In real systems, that's generally not possible to do. And the reason is that when you add a shard, you already have a bunch of existing data. I was just setting it up from scratch. What the traditional design for ClickHouse and sharding is that since ClickHouse typically processes time series data, what will happen is that if you add a shard and then you're inserting time series data, and that time series has those rows have a time to live, like through a TTL, all you have to do is wait till the TTL expires, and at that point you will be balanced. Because old data rolls off, new data rolls in, and as the new data is inserted, assuming that you're going through a load balancer or using a distributed table, your data will be evenly distributed.
In the case my TTL is 1 year, it's going
to be a while. Yeah, that's for you. ClickHouse really needs to reshard it needs to rebalance automatically. So,
or maybe I need to make my TTL smaller.
Or you make your TTL smaller. So, but I think but this is an issue. It's a limitation of ClickHouse, and it's a big one. I think anybody who's used Cassandra understands how great that model is. You just stick stuff in there. Cassandra has a bunch of other problems that ClickHouse doesn't have, but the one thing it does is it balances data.
Okay.
So, great. Any other questions?
Thank you for the explanation. It does help a lot.
Oh, you're welcome. Yeah, anytime.
I'm just now in the middle of designing our from single node to cluster, and I'm thinking how should I do it to make it last.
Mm-hmm. I think that, Tatiana, I don't know about you, but I would have pools. I would think in terms of putting tenants in, having some number of tenants in a pool of servers. And then as soon as you get more tenants, you put them in another pool. And then there's just a lookup to say, hey, which tenant am I using? Then I'll have them go to a different ClickHouse cluster. That's pretty simple to do.
Mm-hmm.
And so 20 years ago, we were doing the same thing with Oracle. We would have customers come in, and the question that our SaaS would ask was, hey, your tenant X, okay, you're going to get Oracle schema for X. And then they would get the connection settings for that Oracle schema.
Mm-hmm. So we should implement in the application some kind of tenant to connection string mapping.
That's whether you should is your choice, but that's been a response to that question for a long time, and I think it's a pretty good one.
Okay, nice. It helps a lot.
Yeah, and I think
it's awesome to talk to you because I was watching your webinars.
Oh yeah, thanks. I think what's cool too about Kubernetes, if I can just sing its praises for a minute, with Kubernetes, with what Graham showed you a minute ago, it's so easy to bring up clusters that you can actually have separate, you can just have a Kubernetes cluster and you can have like all the tenants, some set of tenants just live in their lock, stock, and barrel. And then you can have another cluster and another group of tenants lives there. This is something you can set up in Amazon pretty easily using EKS, or you can use GKE. And it groups your tenants, and it means, hey, if you have a problem, like if Kubernetes has a problem, well, only one set of tenants will be affected, and you have kind of a natural scoping mechanism. I mean, that's a way to do it. Might not be the right one for you, but other people do similar things.
Okay, great idea.
Any other questions?
Not, thank you.
Anybody else?
Thank you a lot.
Oh, you're welcome. Good. Well, thank you, everybody. Let me just make sure there's nothing else on the stream. Nope, don't see it. So thanks, everybody. We're going to go ahead and stop the meeting. Have a great day. And if you have more questions, feel free to hit us up on our Slack channel, or just find us at info@altinity.com. We're always happy to follow up. So thank you very much and have a great day.
Thank you.